Hey Jason, so now we're going to talk about the lesson 20 self-checks. Lesson 20 is all about conics. Conics are like shapes on graphs. So there are 4 different conic sections that we're going to talk about: parabolas, circles, ellipses, and hyperbolas. What I'm going to expect you to do for these is, is to be able to graph them based on an equation, and then to put an equation into standard form to find some information about them. So we're going to start with sub 20.1, which is about parabolas. And the standard form for a parabola is y equals a x minus h squared plus k, where h comma k is your vertex, and then a is like the stretch or shrink. Now I just emailed you the lesson 4 videos, and we talked about kind of how like it moves left, right, up, down, and then it goes inside versus outside the parentheses, and then when the number's right next to the x in the front, that means it's stretching or shrinking. That's basically what this is. So let's just go over the first example. The first example is the first question is 1/3 x minus 5 squared plus 4. The first thing I'm going to do is find my vertex. My vertex would be 5, 4 in this case. Notice that you switch the sign on the inside of the parentheses, but the outside of the parentheses stays the same. And so when I graph these, I'm going to just start with that. So I know it's 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. So there's my vertex. And then the 1/3. Now, if you remember, we talked about this 1, 3, 5 rule. In normal parabolas, it goes 1, 3, 5. But when you have a number in front, it changes it. So you have to multiply 1, 3, 5 by 1/3, which goes 1/3, 3/3, which is 1, and then 5/3. So in this case, I'm going to go up 1 over 1/3, up 1/3 over 1, up 1 over 1, and then up 5/3 over 1. So up 1/3 over 1, then up 1 over 1, then up 5/3 over 1. So this is what it kind of looks like, and there's my graph. Okay, great. So that's how you graph them. Now let's go over how to put them into standard form. So questions 6 through 10 ask you to put it into standard form or the vertex form, and then write the equation for the parabola. So this is a lot of completing the square stuff. This whole lesson is about has a bunch of completing the square. Good news, you're really good at it. So number 6 says negative x squared plus 16x plus y minus 62 equals 0. So the first thing I'm going to do with parabolas is solve this sucker for y. So if I solve this for y, I would get y equals x squared minus 16x plus 62. Now, to put this into vertex form, what I'm going to do is move the 62 back over next to, this is called standard form. We want to put it in vertex form. It's just easier to get it into standard form first to kind of start fresh. From here, what we're going to do is move the 62 back over so it says y minus 62 equals x squared minus 16x. Then we're going to use the completing the square formula, which, if you remember, is b over 2 squared. B is the number with just one variable, so in this case it's negative 16 over 2 squared, which would give us 64. What I'm going to do is add 64 to both sides, so I'd get y minus 62 plus, I'm thinking ahead of myself, so y minus 62 plus 64 equals x squared minus 16x plus 64. This is a perfect square, which means I could factor it using the box method, or if you remember the trick way, you just take the middle number and divide it by 2, so I can change it to x minus 8 squared equals, and then if I simplify this, I get y plus 2. Now I can move the 2 back over to the other side, and I get y equals x minus 8 squared minus 2. This is your vertex form. So that's what I want to see for number 6, and then I also want you to be able to tell me the vertex, and the vertex in this case would be 8 comma negative 2. Okay, and then if you remember, I just want to go over this really fast because some of them, like number 8 and 9 and 10, all have them. So I'm just going to go over, for number 8, I'm going to put it into standard form really fast. You get y equals 2x squared plus 20x plus 58. So the setup's the same. You move the 58 back over, y minus 58 equals 2x squared plus 20. Then because there's a number in front of the x squared, you have to take that 2 out, or factor the 2 out of the front, or out of the right side. So you get y minus 58 equals 2 parentheses x squared plus, sorry, that should have an x on it, 10x. Then you do the b over 2 squared, which is equal to, in this case, 10 over 2 squared, which is 25. Normally I would just add 25 to each side, but if you remember this from when we were completing the square, you add 25 to the inside of the parentheses, which is great, but then you have to not just add 25 to the other side, you have to do 2 times 25, because you're not really just adding 25 to this side because the 2 is multiplying the 25, so we add 50 to that side. That's the only difference between like number 6 and number 8, 9, and 10. So you should be good from there. Now let's look at our self-check 20.2, which is about circles. The standard form for circles is x minus h squared plus y minus k squared equals r squared. I swear we've done this before, but I can't remember. So the center is h comma k, and then your radius is just r. So when we graph something, for example, number 1 says x plus 1 squared plus y minus 3 squared equals 16. What that tells me is that the center is -1, 3, and then the radius is the square root of what it's equal to, so the square root of 16, which is 4. So when I graph that, I'm going to start at 1, -1, 3, and then the radius is 4, so I'm going to go up 4, to the right 4, to the left 4, 1, 2, 3, 4, and then down 4. That was too many. And then we can just draw our circle. Obviously, I'm not a great artist, but that's what it should kind of look like. Okay, so to put them into, like for the second half, I'm asking you to put them into a standard form. So like this format right here. So let's just go through number 6. I have x squared plus y squared plus 4x plus 30y plus 220 equals 0. The first thing I'm going to do is get the x's together, the y's together, and the thing without the x or the y on the other side. So I'm going to have x squared plus 4x plus y squared plus 30y equals -220. Now, if you notice, this chunk and this chunk are kind of like what we started with the parabolas. So we're going to use that b over 2 squared, the completing the square formula, for both the x's and the y's. So for the x's, you'd have 4 over 2 squared, which is 4. And then for the y's, you'd have 30 over 2 squared, which is 15 squared, which is 225. Okay, so then I'm going to add that to both sides. So I'd get x squared plus 4x plus 4 plus y squared plus 30y plus 225 equals -220, but then I have to add those other things to the other side, so plus 4 plus 225. Excuse me. So now this is a perfect square, this is a perfect square, so I can write them as x plus 2 squared, because I just divide by 2, and then y plus 15 squared. I can put a plus sign in the middle of them, mostly because there's a plus sign right here, equals, and then I add all of those together, and I get 9. From there, so that's your standard form, that's great. From there, I want you to also be able to find your center and your radius, which you should be able to. Okay, the next self-check is 20.3, which is ellipses. Ellipses are like ovals. Let me find some more space. Okay, so the standard form of an ellipse is x minus h squared over a squared plus x minus, or I'm sorry, y minus k squared over b squared equals 1. So when we graph, or let's see, so the center is the same for the circle. It's just h comma k. And then I also want you to find, it tells you to find the foci. I don't want you to find the foci, but I also want you to find the vertices and the co-vertices. So the vertices, ellipses are oval. So the vertices are like the edges or the corners of the edges of the longer side, and then the co-vertices are the edges of the shorter side. It depends on which one's bigger. So if A is bigger, I guess if A squared is bigger, then A is what we call the major axis. And then if and then B squared is small, B squared would be smaller, right? And if B squared is smaller, then B is called the minor axis. And I'll show you how to do that when we graph it. That way we can find the vertices and everything. But so for the first example, we have x minus 3 squared over 16 plus y squared over 25 equals 1. So the center here would be 3 comma 0. It's 0 because that y doesn't have anything on it. Like it's just a y squared, so it's automatically 0. So I'm going to just start by graphing that. So 3 comma 0 is right here. Then what I do is I take the bottoms of the fractions and I square root them. So if under the x is 4, like the square root of 16 would be 4, and under the y is 25, square root of 25 would be 5. Do you see how, so the y has the bigger number. What that tells me is that what I'm going to do is go 5 up and 5 down on, like, from my center. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the x has the, like, the square root of 16 is 4. So because it's x, I'm going to go left and right. 4. 1, 2, 3, 4. 1, 2, 3, 4. And here is your ellipse. Sorry, obviously not a great artist. So this thing right here is the major axis, and then this one would be the minor axis. These right here are your vertices, and then these ones are your co-vertices. So like, I also want you to be able to say, oh, my co-vertices are -1 comma 0, and let's see, 3, 4, 5, 6, 7, 7 comma 0. And then my vertices are this and this. I want you to be able to write those points down. Number 2 doesn't have a number on the bottom of the y's. Just make it 1. And so like you could rewrite it as x squared over 36 plus y squared minus 1 squared over 1 equals 1. And then, so then the next section, asks you to put things into standard form. This is really similar to the circles. It just takes a couple of extra steps. So let's go through number 6. Actually, let me look. Let's see. I want to go through number 8, mostly because that one is the most complicated one. Or the one that has... Yeah, let's go through number 8. Okay, so we have 25 x squared plus 9y squared plus 50x plus 72y minus 56 equals 0. So again, I'm going to get the x's together, the y's together, the thing without the x or the y on the other side. So it's 25x squared plus 50x plus 9y squared plus 72y equals 56. Now, notice that there's numbers in front of the x squareds and the y squared, so I've got to factor those out. So I'm going to say 25 x squared plus 2x, because 50 divided by 25 is 2, plus 9 y squared plus 8y, because 72 divided by 9 is 8, equals 56. Now I do the completing the square, which is the b over 2 squared. So for the x's to be 2 over 2 squared, which is 1, and then for the y's to be 8 over 2 squared, which is 16. I add that to both sides, so I get 25 x squared plus 2x plus 1 plus 9 y squared plus 8y plus 16 equals 56. And then instead of just adding 1 and 16, we have to add 25 times 1, which is 25, because that 25 right there is multiplying the 1 right there, and then 9 times 16, which I don't know what that is. Let me do it on my calculator. Let's see. 9 times 16 is 144. So plus 144. Okay, put them into the prettier form. So 25x plus 1 squared plus 9 y plus 4 squared equals, let's see, so 56 plus 25 plus 144 is 225. Okay, so then what we're going to do from there is we want to get the 225 to be 1 because our standard form is always set equal to 1. So what I'm going to do is divide each chunk by 225. And then from there, I'm going to simplify just the outside. So like the first chunk is 25 divided by 225. So 25 divided by 225 is 1/9. And so I can write that as x plus 1 squared over 9. And then if I do 9 divided by 225, I would get 1 over 25. So I can write y plus 4 squared over 25. That's equal to 1. I put a plus in the middle. And there's my answer. I just want you to get the equation this time. You don't have to write the vertices and the covertices and all of that. Okay, the good news is that the hyperbolas are literally the same thing. The only difference is that there's going to be a minus in between. So like this is your standard form for an ellipse. The standard form for a hyperbola would be x minus h squared over a squared minus y minus k squared over b squared equals 1. Sometimes you can have the x in front, sometimes you can have the y in front for the hyperbolas. The only difference is just depending on the equation. If there's a negative in front of the x squared, then the x goes behind. If there's a negative in front of the y squared goes behind. When you graph hyperbolas, so I don't have the self-check pulled up, but let's say that we have like x minus 1 squared over 9 minus y plus 2 squared over 25 equals 1. You're going to do the same thing where you find the center the same way. So the center would be 1, negative 2. And then we square root both of these, you get 3 and 5, right? So then what I'm going to do from there is, because the 3's under the x, I'm going to go 3 to the left, 3 to the right. The 5's under the y, so I go 5 up and 5 down. 1, 2, 3, 4, 5. Then instead of making a circle, what I'm going to do is make a box. Now, this is like, you don't have, here's the deal. The hyperbola doesn't have the box in it, so it's kind of like a fake line or a line just to kind of keep our thoughts straight. Then what happens is we have these asymptotes. So the asymptotes create an x between the corners of the box and the center. Then from there, we're almost done. Notice how the x is in front. When the x is in front, then it's a horizontal hyperbola, which means that what's going to happen is it's going to go like this. And then this side also goes that way. If the y was in front, then you would do the parabolas up and down instead of left and right. Hopefully that makes sense. Okay. There's one more thing that I have to show you, but my kid is being ridiculous, so I will send that to you in a different video.